Today I'm going to give you some review work to do for vectors because we're going to have a quiz tomorrow on vectors and wrap up this part of chapter 6 I think we're in. So first I'm going to give you vector u. Vector u has its head at -2, -4. I'm sorry, its tail at -2, -4, and the head is at -6, -12. Here's the vector v. Vector v has a tail at 3, -4, and the head is -1, 5. So I'm going to have you find some various facts about these two vectors, u and v. And after I ask you to find them, what you should do is shut off the video and calculate them yourself, and then I'll show you what the correct answers are just so you can check your work. So hopefully you've written down the facts about u and v, and here are the things that I want you to find about u and v. First of all, can you write each one of those vectors in component form? Number 1. Number 2, can you find the magnitude? Oh, you might just well find the magnitude of both of them. And the direction of both of them. Zero, 1, 2, 3. Can you find the difference between them? And you might just as well find the sum, u plus v. That'll be easier, probably. Number 4, can you get a unit vector in the same direction as v and another unit vector in the same direction as u? Same exercise. Done to both vector u and vector v. All right, now I'm going to show you a vector that I'm not going to give you the endpoints of. Here's a vector that has a magnitude of 200, and the angle between the y-axis and the vector is 60 degrees. So here's 60 degrees from here to here, 60. Magnitude is 400. Can you find the component form of vector w? So you can shut off the video right now and compute all of those, and then you can check your answer when you're done. First of all, the component form of u is you're actually going to subtract head minus tail. You get -4, -8. And of v, head minus tail, the coordinates would be -4, 9. Magnitude. The magnitude of u is equal to the square root of x squared plus y squared, 16 plus 64, which is the square root of 80, which can be broken down into 16 times 5, which is 4 square root of 5. And the component form, or the magnitude of v, is the square root of x squared plus y squared, which is 16 plus 81, and that is the square root of 97, and that can't be simplified. Direction of v. Well, v turns out to be, if you draw that in standard position, it's in quadrant 2. So you're going to get a reference angle by using inverse tangent and then subtracting that from 180. So the direction of v is 180 degrees minus the inverse tan of, I don't know why I'm doing v first, but I am. And then you can put in 9 divided by 4. It's y divided by x. So if you do that math, you get 114 degrees, I believe. And the direction of u, now u would turn out to be a quadrant 3 angle if you move that back to standard position. And so in quadrant 3, you're going to do 180 plus the reference angle. So the inverse tangent of negative 8 over negative 4, I'm going to put 8 over 4 y over x. And if you do that, I think you get 243 degrees, if you round those to the nearest degree. Number 3, if you subtract u minus v, you should get 0, negative 17. And if you add them together, you should get negative 8, 1. Unit vectors in the same direction. All you do is take the component form of each vector and divide it by the magnitude. So let's do a unit vector of u. And so the magnitude of u is 4 square root of 5. So we're going to take each of the x and y and divide it by 4 square root of 5. And we've got negative 8 over 4 square root of 5. And we wouldn't leave it like that because the 4's can be canceled here. And so you're left with negative 1 over the square root of 5. And 8 over 4 is 2. So negative 2 over the square root of 5 would be the component form of u. Of the unit vector in the same direction as u. And the unit vector in the same direction as v. V's got a magnitude of square root of 97, so that's not going to be simplified. So that would be negative 4 over square root of 97 and 9 over the square root of 97. Okay, item number 5. I wanted you to find the component form of that angle that was down in quadrant 4. So component form is magnitude, 200, times the cosine of the angle. Well, I gave you a 60-degree angle from the y-axis, so that actually turns out to be 330 degrees. 200 sine of 330 degrees. Now this is something that I don't want you to use your calculator on, because this has a reference angle of 30 degrees, which is in quadrant 4. So here's quadrant 4 angle. Reference angle is 30 degrees. Cosine in quadrant 4 is positive, so this is like saying 200 times the cosine of that reference angle, 30 degrees. And the sine goes negative in quadrant 4, so this is negative 200 times the sine of the reference angle, which is 30 degrees. And you need to know the cosine and sine of 30 degrees. Cosine of 30 degrees from your 30, 60, 90 triangle, or however you've memorized that, is the square root of 3 over 2. So you're going to multiply those together. And the sine of 30 degrees is a half. So when you do that multiplication, you're going to get 100 square root of 3 positive and negative 100. So there's your answer to number 5. And that's about it for right now. I'd like you to know the sine, cosine, tangent of all the 30-degree, 45-degree multiples in all quadrants. So you need to know sine, cosine, tangent of 30, 45, and 60 in quadrant 1, of 150, 135, and 120 in quadrant 2, 210, 225, and 240 in quadrant 3, 330, 315, and 300. And these are all in degrees. You don't have to worry about radians with this chapter. And this is in quadrant 4. So make sure you know, if you know the sine of 30 is a half, sine of 45 square root of 2 over 2, sine of 60 is a square root of 3 over 2, and then the cosine of 30 is the same thing as the sine of 60. So the cosine of 30 is a square root of 3 over 2, cosine 45 square root of 2 over 2, cosine of 60 is a half. And then the other ones you have to know are tangent. Tangent of 30 is the square root of 3 over 3. Tangent of 45 is 1. And tangent of 60 degrees is the square root of 3. So make sure you know those values. And you also have to consider ASTC, that the sine is the only positive trig function in quadrant 2, tangent's only positive trig function in quadrant 3, and the cosine's the only positive trig function in quadrant 4. And the other thing that you're going to have to know is the equilibrium type of problem that we did today in class, where you'll have a hanging object, and I'm going to ask you to find the tension in the two cables that are suspended holding those. So if you have any questions, hopefully you can see me before we have our little quiz. The last example I'm going to do is from your packet that I gave you on vectors, and I started doing this one in my other video, but I realized that they didn't give us any angles to work with. So this problem, we're going to have two cranes lifting an object that weighs 19,080 pounds. Find the tension in the cable of each crane. Well, this is my diagram, so you can just follow this. I said, here are the two cables. Here's the object that weighs 19,080 pounds, and I just made up a couple of angles. I said this angle will be 65 degrees and this angle will be 40 degrees. So what is the tension on each one of these cables? Well, the tension is just the amount of force. So I'm going to call this F1, and I'm going to call this F2 for these two vectors. And this, if I define this to be the x-axis, then this angle over here will be a quadrant 2 angle. This is how I've worked these out in the past couple of days. So this angle right here, theta 1, I guess we can call it, we'll call this 140 degrees because it's 180 minus 40. So here's an angle right here, we'll call it 140 degrees. And if I wanted to get the component form of this vector, then it would be the force 1 times the cosine of 140, force 1 times the sine of 140. So there's your first vector in quadrant 2. The second vector is in quadrant 1, and this angle down here, if this angle is 65 degrees, then this angle right here is 90 minus 65, which is 25 degrees. So this second force, or this second vector, can be defined as force 2 times the cosine of 25, force 2 times the sine of 25. So I'm going to set up my x components, which are f1 cosine of 140 plus f2 cosine of 25, and set that equal to 0, just like we've done on the other ones. And then if I wanted to solve this for the first force, I subtract f2 cosine of 25 from this side and divide both sides by the cosine of 140. So if you solve this for f1 in terms of f2, you should get this. f1 is equal to negative f2 times the cosine of 25, which is the negative of this, divided by that. So that's an important part of this. If I want to set up the y components, f1 times the sine of 140 plus f2 times the sine of 25 is equal to, or if you wanted to say minus the sine of 270 times 19080, you can, but you knew that was negative 1, so you could just move that over to the other side. Hopefully we've done enough of, a couple of these problems to realize that this becomes negative on the left side of the equal sign, so you can make it positive over on the right. And so now we have a system of equations, and we're going to use the substitution method. So this f1 right here, we're going to take out the f1, and we're going to replace it with what we solved it for. So we're going to replace this with negative f2 cos 25 over cos 140. and then we're going to add the rest of that and make it equal to 19,080. So here's the substitution into F1 right here, and then here's your sine of 140, and then plus the rest. And what I do next is, because I have a common factor of F2 in this next equation, I'm going to factor out the F2 and pull it outside of the front and make it in front of the parentheses. So here's the GCF pulled out, and you're left with negative cos 25 sine 140 over cos 140 plus the sine of 25 is equal to 19080. Now this is where I'm wondering if I'm correct in my answer, because when you solve this for F2, you get 19080 divided by this whole great big monster right here. And if I do that, I believe I get 16,127.113 if I round it to 3 decimal places. And hopefully you can check my math to see if I'm right. Now the strange thing is solving for F1, because F1 is equal to, from way back up here, F2, which we found to be this. So it's negative F2, negative 16,127.113 times the cosine of 25 divided by the cosine of 140. And when I solved that for F1, actually I didn't round this in my calculator. I put the whole thing in my calculator. I got 19,080, which is the weight of the original force, which makes me suspect that maybe I've done something wrong mathematically. So if you can check, if you can find my mistake if I made one, that would be wonderful. But if that's all good, then that's just a typical equilibrium problem where you have one object hanging down from a ceiling, and you know what the two angles are from above. And study free quiz.